All right, so we've got a couple examples here where we're going to apply that reduced triangle idea. So again, the idea of the reduced triangle is just to make the problem easier, allowing us to work with smaller numbers. So what we do is we look at the given sides, 55 and 77. If those numbers can be divided by a common factor, let's go ahead and do that and make the problem easier. So 55 and 77 can both be divided by 11. So we want to remember that that's what we're doing on these problems. So 55 divided by 11 is 5, so that's our reduced side. 77 divided by 11 is 7, so that is our reduced side. So, do we have a Pythagorean triple that has 7 for the hypotenuse? And because we don't, we're going to go ahead and use the Pythagorean theorem. But we're going to use the Pythagorean theorem with our reduced easier sides. So 5 squared plus, now make sure you take note on this 7 is actually the hypotenuse. So that's going to go on the other side of the equal sign. So 5 squared plus x squared equals 7 squared. All right, then we get 25 plus x squared equals 49. Go ahead and subtract 25 from both sides. So x squared equals 24. Now we square root both sides, and then the square root of 24 is not a perfect square, so we try to reduce it. Reduces into 4 and 6. So x is equal to 2 times the square root of 6. Now remember, that is the reduced answer. And because up here we divided by 11 to get the reduced numbers, we're going to do the opposite of that. We're going to take our answer and multiply it by 11. So I'll go ahead and write that up here. We're going to multiply, what did we get? 2 times the square root of 6 times 11. 11 times 2 is 22, and that square root of 6 just stays. So our missing side is 22 square roots of 6. All right, how was that one? Awesome, great, you loved it? Okay, good. So example 2, this one, we have 3, and then 4 is the hypotenuse. It's really tempting to say that this is a 3, 4, 5 triangle, but remember, in a 3, 4, 5 triangle, 5 would have to be the hypotenuse, which is not the case here. Can we reduce our numbers? Can 3 and 4 be divided by the same number? No. So in this case, we can't reduce the triangle. We'll just go straight to the Pythagorean theorem. So 3 squared plus x squared equals 4 squared. Remember, 4 I put on the other side of the equal sign because that is the hypotenuse. All right, 3 squared is 9. Then we have x squared. 4 squared is 16. So we get the x squared alone. 16 minus 9 is 7. Square root both sides. X equals the square root of 7. And because that cannot be reduced, that is your final answer. So square root of 7 is our missing side. Because we didn't have to reduce the triangle, we don't have to multiply our answer in the end.